Hello, welcome to Houston-Galveston Area Council's Homeowner Wastewater Education. This module is the first of 5 modules of the On-Site Sewage Facilities Homeowner Education. In this module, we will explain what an on-site sewage facility, or OSSF, is. You may not recognize all the terms used in these videos. Scan this QR code with your phone for a complete glossary of terms for all modules. In Texas, OSSF stands for On-Site Sewage Facility. Nationally, they are referred to as On-Site Wastewater Treatment Systems, or OWTS. On-site sewage facilities are often referred to as septic systems, but this is not always the case. The 2 most common types of OSSFs are a conventional or traditional system, which is an anaerobic system. These are truly septic systems. The second type is an aerobic system, which utilize pumped air or oxygen. These are not septic systems, but are often incorrectly referred to as septic systems. The 2 most common types of aerobic systems are a spray system and a drip distribution system. OSSFs are used in areas where centralized residential sewers are not available. OSSFs treat sewage and remove contaminants before they can reach and contaminate groundwater or surface water. OSSFs can dispose of up to 5,000 gallons of sewage per day, but typical residential systems dispose of between 500 and 1,500 gallons of sewage per day. Within the 13-county Houston-Galveston Area Council region, there are more than 364,000 OSSFs, with an estimated 60% of them being unpermitted. Let's dig a little deeper into the components of an on-site sewage facility. This diagram is of a conventional OSSF, or a septic system. Conventional OSSFs have been common for almost 100 years. They are simple gravity-fed systems. There are no mechanical or electrical parts to the system. Here are the 4 general components of a conventional or a septic system. The wastewater source, which is the sewage pipe from the building or dwelling into the system. The collection and storage tanks, which is typically 2 compartments made from concrete, plastic, or fiberglass with access ports above ground. The disposal system, which in the case of a conventional OSSF is a drain field. And the soil, which in a conventional system is where the final wastewater treatment occurs. Now let's look at an aerobic system, sometimes referred to as an ATU. Compared to a conventional septic system, aerobic systems are more complex. These systems have mechanical and electrical components, including motors and pumps. An aerobic system will consist of 3 general components, which include the wastewater source, which is the sewage pipe from the building or dwelling into the system, the collection and storage tanks, which are comprised of single compartment waste collection tanks and an aerobic treatment tank. Both of these tanks are typically made from concrete, plastic, or fiberglass. And the disposal system, which is typically made up of a chlorinator and a pump tank, along with a gravity-fed drip system or spray field. The spray field uses treated water for lawn sprinkler systems. The soil filters and further treats the treated effluent before it reaches the groundwater. Now let's compare the components of both types of systems. Both types of systems are buried in water-type receptacles to receive liquid and solid waste from the home. The tanks are generally made from concrete, plastic, or fiberglass. The tanks hold the household human waste so it can separate and settle. The solid waste, called the sludge, separates from the liquid waste and settles to the bottom of the tank. The floatable waste, such as fats, oils, and greases, referred to as scum, will rise to the top of the tank. It is here where bacteria digest the organic waste. The conventional septic system, which is the system on the left, has a septic tank which is anaerobic, which means it works without oxygen. This is where waste is held so it can separate and settle out. The aerobic system, which is the system on the right, has a collection tank which is very similar to a septic tank. But this system also has an aerator to pump oxygen into the system. Here the oxygen agitates the effluent and provides energy for aerobic bacteria to break down the waste and create clean effluent. Some aerobic systems, such as the one in the picture, have a single chamber system, while other systems have a collection tank and an aerobic tank. From the collection and storage tanks, the effluent flows into the disposal system. In a conventional system, the clarified liquid from the collection tank will move to the drain field. The drain field is gravity fed with no moving parts or pumps. Treated wastewater moves further into the drain field as more wastewater leaves the collection tank. Drain fields typically consist of perforated PVC pipes surrounded by gravel or sand. The sand and gravel surrounding the perforated pipe serves as a filter for the effluent. Aerobic systems typically have a chlorinator, a pump, and either a spray irrigation or subsurface drip for disposal of treated effluent. The chlorinators further treat the wastewater with chlorine for dispersal of the final clarified liquid. Aerobic systems work better in areas where conventional systems aren't feasible due to soil limitations. Clarified liquid is dispersed using either a sprinkler system or a drain field. Note, in both conventional and aerobic systems, the disposal system is often where problems with the OSSF usually occur. The last component of the OSSF is actually the soil itself. In conventional septic systems, the soil is the last part of the effluent filtration. Wastewater from the drain field percolates down into the soil. Microorganisms in the soil remove nutrients and harmful pathogens. The soil actually forms a biologic mat, preventing wastewater from saturating the soil below. Microorganisms in and below the mat provide the final treatment to wastewater before it enters groundwater. In aerobic systems, the soil also performs a valuable function in the treatment of effluent. Although the effluent has already been treated with chlorine, not all pathogens have been eliminated. The soil provides another layer of decontamination for the treated wastewater. A word of caution, if the chlorinator in an aerobic system fails, it can cause issues with wastewater runoff if the soil cannot absorb it. Lastly, let's compare the pros and cons of the two systems. The pros for a conventional system are they are a simpler system, there are no mechanical or electrical parts to break, they have a longer lifespan, and they are typically less expensive to install and maintain. The pros for an aerobic system are the aerobic bacteria are much more effective at breaking down waste. They can withstand household cleaning products better. They offer alarm systems to alert the homeowner to any issues with the system. They allow for the recycle of treated water for watering lawns. They have a smaller footprint, so they are better for smaller yards. And they can be used in poor or impermeable soil conditions. The cons of a conventional septic system are they are not as effective at breaking down household cleaners. They need a large plot of land to be effective for the drain field. They can't be utilized in impermeable soils, and they have no alarms to detect early problems or malfunctions. The cons of an aerobic system are they are not as effective at breaking down inorganic material. They have a higher chance of clogs and backups. They are more expensive to install and maintain, and they need a steady flow of wastewater. Thus, they are not suited for weekend or part-time homes. Scan this QR code with your phone for an automated self-guided tour of how OSSFs work. These videos are designed to educate homeowners on the basic functions and general maintenance of OSSFs. Watching the videos does not qualify a person to perform the work of a registered sanitarian or licensed OSSF installer or maintenance provider, or to maintain their own system. If you are interested in maintaining your own system, please contact your local permitting agency to check on their maintenance requirements. This project is funded in part by the Texas Commission on Environmental Quality through a grant from the United States Environmental Protection Agency. This completes Module 1 on what is an OSSF. We at H-GAC hope you found this informative and encourage you to continue our series with Module 2, Why are OSSFs necessary and why should I be concerned with my OSSF?